In this video, we show a little bit about how the presence of APsystems in the world, all the products that we manage. And now we are going to talk about this information, the information we saw on the video, but already in data. We were founded in 2010 in Silicon Valley, and this was where the APsystems were found. Now we are based on China, and around the world we have more than 3.5 gigawatts already installed. We have presence in more than 100 countries, and nowadays we are the worldwide leader on microinverters. We have more than 100 patents and more than 100,000 installations in the world. Now we are going to talk about how APsystems brings technology to photovoltaic systems. Our objective is to improve all the energy that we can obtain from the modules. So we are working on microinverters that can work with 2 or 4 PV modules. And in the market, we have more than 12 years, and we are developing the module level power electronics that give us the opportunity to improve all the energy that we can take from the PV modules, and it allows us to have the better development, or a better development in our entire system, because we are always trying to have the best energy or the better energy from our modules. Here we have a timeline about how the products have been developing during these years. The first microinverter that we put in the market was the YC250. This one was launched in 2011. And then the next one was the YC500. This one duplicates the power that we have in the first one. And during the years, we have been improving the power that we can obtain from our modules, always trying to go along with the development that we have in the PV module side, because every year we have improvements in that part. So in APsystems, we are working to always going at the same level with the modules, so we can work with the newest models in the market. So in 2016, we launched the YC600 and the YC600B. And in 2018, we launched the YC1000. This one was a three-phase microinverter. And then in 2019, we launched the QS1. This one was 1,200 watts. And then the next year, we improved the power output on this microinverter with the QS1A. In this one, we have 1,500 watts. And the recent, or one of the recent launches that we had was the DS3D. This one is the microinverter that we have nowadays with the highest power output, with 2,000 watts of power. This year, we also relaunched the YC600B with improve in the output power with 750 watts. And in this year, we are launching 2 devices, the DS3H and the QT2. The DS3H, it's a complement or come to the market to work with the DS3D hand-to-hand to have better installations. And in the QT2, it's a 3-phase microinverter that allows us to install a microinverter that is already native in a 3-phase in our installations. And with this one, we can avoid to balance the phases in our installations. That is something that we need to do when we install the S3D. Now we are going to talk a little bit about what is a microinverter, what it does. So it basically transforms the direct current that we obtain from the PV modules to an alternating current that we use most of the time in our sites, like in our houses, in the commercials, and also in industrial installations. So this device allows us to use the energy that we can obtain from a PV module in our installations. And in our microinverters, you can connect from 1 to 4 modules. So if you only have one module in your installation, you only need one, you can use our microinverter with one PV module with any problem. Then we have here we have some of the principal benefits that we have, that we manage the module level power electronics. We are all the time trying to get the best of every module that we have connected in our MPPT. We have multiple MPPTs. It allows us to connect different types of modules photovoltaics in a same installation. This is an advantage because we don't have to take care every time to connect the same PV modules. We just need to see that it's compatible with the characteristics of the MPPT, and we can use it. Also, we have the plug and play installation that the meaning is that you just need to connect the microinverter, and it by itself is going to synchronize with the grid and start working properly. In our microinverters, we already have our AC outputs, so all the part or the cables are going to be in AC, so it is cheaper to install the AC parts. And also, we have maximize our safety because we are only work with low DC voltages that allow us to work in a safe environment. Also, this is an easy operation and maintenance because we just need to verify every certain time to verify if the connections are in a good conditions and if the microinverter is not exposed to the environment directly. That's all that we need to do with the microinverter in the maintenance part. As we talked before, the MPPT is to improve the generation, and it allows to install our models in different height, angles, orientations, and also in presence of shadows. Why? Because the part of the work of the most important point of the MPPT is this one is always going to be looking for the better or the best current and the best voltage to obtain the maximum power output on this model. So our MPPT is always working on that. Since we have multiple MPPTs, we can use different PV models from different powers with no problem. Also, APsystems has built an environment where you can find all the devices or all the products that we have to have a full picture of your system. First of all, we have our microinverters. They are the ones that do the energy transformation. Then we have the energy communication unit, or ECU. This one is the one that recollects all the information from the microinverters, and it send it to the EMA, that it's our energy monitoring analysis system, when we can see in a visual or graphically way and all the information that we are collecting from our system. Now we have all the products that we have now in the market on microinverters. We have the YC600B. This is a single phase microinverter. We have a 750 watts on output, and this one works with PV modules of up to 550 watts. Then we have the DS3D. This one is the microinverter that have the highest power output that we manage. That is 2000 watts. And from this one, all the microinverters that we have work with PV modules up to 670 watts. Then we have the DS38. This one is also a two-phase microinverter. We have an output of 1050 watts. And then we have the QT2. This one is a three-phase microinverter, and we have an output of almost 1800 watts. All the microinverters have a Zigbee communication, so this information is going to be shown in all the slides on all the products. Every microinverter has its own Zigbee antenna, and this one allows the communication between the microinverter and the ECU. This one, the Y6600B, have two MPPTs, and we can connect one module on each one. These are the basic parts of this microinverter. We have the coupling system, the AC connector, the AC cable, the connectors or channels where we are going to connect the PV modules, and LED indicator. In this one, we can see if the device is working properly, if it's communicating with the ECU. And also we have the Zigbee antenna that is going to allow the microinverter to send information to the ECU. Then we have here the datasheet of this product. We have that we can work with this microinverter if we are going to use PV modules that are in this range of voltage from 16 volts to 60 volts, and also with a maximum input current of 14 volts. This is per channel. Then we have the DS3D, as we talked before. This is the one that we can offer with the maximum output power of 2000 watts. In this one, we can connect 4 modules, but this is important to mention that in each MPPT, we need to connect at least two PV modules in series to reach the voltage of operation of that MPPT, and then we can put this microinverter to work. These have a 97% efficiency, and here we have the datasheet of this product. This one have an operating voltage range of 52 volts to 120 volts, and the maximum input current that it supports is 20 amperes per channel. This current is really good for the market, since nowadays the models that we have in the market are working with currents up to 18 amperes. So we can work with these PV models with any problem with the DS3D. And here we have some information about how to do the connections, especially with the DS3D. Since we need to connect 2 models in series, we need to verify that we are connecting the right cable to the right channel. If we cross all the cables that we have in our series, we can damage the DS3D or the microinverter, and it's considered as a bad practice, and the warranty is not going to be valid in this case. So it's important always to check if we are connecting the right cable to the right channel in the right channel. Then we have the QT2. This one is a 3-phase microinverter. We have 4 inputs. In this one, we need to connect 1 PV module per channel, and the maximum current that we work with, it's 20 amperes. Also, we can work with high voltage PV modules. It works with low voltage in DC, so it's a good way to work safely. And also, we can avoid the balancing of the charges in our installation with this one, since this is a three-phase in a native way. Here we have the datasheet again, and we have that the maximum input voltage that we can work with per MPPT is 60 volts, and the maximum current again is 20 amperes. Also, in all the datasheet of all the products, we can find information about how many devices we can connect in series, depending on the cable that we are going to use in the installation. Here we have an image where we can see that we need to connect one module per channel. It's quite different from the DS3D, but in the Kit2, we just need to use one module per channel. And finally, in the products, we have the DS3H. This one, it's also this is a biphase microinverter, and in this one we also have low voltage in DC. We work with 60 volts in DC, and also we just need to connect one PV module per channel. This is a complement of the DS3D, because in the DS3D we need to we need to connect 2 modules per channel, and when we have an installation with 5 PV models, we can use a DS3H to solve that part and just connect one module to one of these channels and leave one to a possible increment on the power of the system. Also, we have the same voltages of working 60 volts and 20 amperes per channel. We have a little image here where when we can see that we can connect one module per channel, and it will work properly. And now we are going to talk about the ECU, and my partner here, Alfredo, is going to continue with the presentation.
Okay. Yes. Okay. Good afternoon for everyone. My name is Alfredo Medina. I'm Soemi's partner. So as Soemi mentioned before, we have some options of microinverters depending on the installation we have. For example, we have options for residential and also commercial, and it depends on the demand of the client, or it depends on the kind of installation that we would like to install our products, the product we need to use. So to complement the microinverters, okay, we need to have the microinverters to generate electricity, and also we need to have the ECU. The ECU is basically the energy communication unit that the main task that this device develops is to communicate the communication between the inverters and also the ECU and the internet connection. So it basically collects information from the systems, and also you can see graph, you can see some analysis from the systems, the production, and that will be very, very helpful to the final user. So yes, let me just change the slide. I'm having troubles here with the slides. Okay, so what is the main function of the ECU? Okay, as I mentioned, we have the micros, then we have the ECU. It's very important to have the ECU, the energy communication unit, because that is the way in which all the system, the microinverter systems, is going to communicate with the internet. So it is very important to have it also, because if you have the microinverters and also you have the ECU, you have 10 years of warranty. And we're going to mention that information in deep later on the slides. So for now, what are the advantages to have the ECU? Okay, you can see the behavior of the systems of the microinverters. It's very important because when you monitorize the micros, you can see some alerts, some alarms for the system. And also if you have any troubles, you can see it through the ECU. For the lectures, we have also the real-time parameters that we can send. So can we see the last? Yes, we have the real-time parameters. So what is this option? In this option, we can make some modifications to the systems to link the AC grid voltages and also the frequency to our units in case we have a problem with the systems. And another advantage is that we have all the system status, and also we have an internal memory on the devices. This memory saves the information from the systems. In case we have a problem with the ECU, we can replace it with a new one without losing any information. We have three types of monitorizing system. The first one is the ECUC, then we have the ECUR and the ECUB. It's very important to know the difference, because knowing the difference, you are going to know which system you are going to connect with your microinverters. First, we have the ECUC. This ECUC is the one that has more options for us. For example, we can control the export of the energy that we give to the grid. So we can activate the zero export, and we can avoid the exportation of energy to the network. This is very important because some networks are like charging some fees for the reactive power, and we can avoid this using the ECUC. And the way this ECU works with the zero export, for the zero export, is through the CTs. It has some CTs that you can activate, you can use to measure all the energy that is flowing to your system and that your system is giving to the grid. So you have many other options that are very important if you need it. So we also have the ECUR and the ECUB. Those ECUs looks the same. If you see how they are, the components they have, but the ECUB is that is this one, the little one. The ECU is for to use with one or two microinverters, and the ECUR, this one that we have here in the middle, you can connect up to 100 devices without any problem. So both are compatible with Wi-Fi, and also the ECUR and the ECUC are compatible with Ethernet connection with the RJ45 cable. So you can use both ways to connect your ECU to the internet. Also, we have here the EMA manager. This works. This is the display of all the systems that we see in our installation. We can use both. We can use it through the cell phone with an application that is compatible with iOS and Android, and also we can see our production for each model in the website, in the APsystems EMA website. So you in that in that web page, you can find the production for each module. This is very important because when you have a system, for example, 40 solar modules, you can see the production of every module. So this is very important because also if you have the installation, if you have some shadows, some bad tilts in the installation, you can avoid these low losses in your system by installing microinverters. For example, if you have 4 modules and each module is connected to one input of the microinverter, if you have a shadow in the module number 1, just that module is going to reduce or decrease the output power, but you are still having the maximum output power for the other solar modules. So this is an advantage for the microinverters. Here we are seeing the main page from the EMA, and also you can see the production from the start of the day to the end of the day. Also, we have in the official APsystems application, you have so much options here. You can add some microinverters. You have the option also to connect the ECU to the network, and also you can decide the profile of the grid that you want to use. For example, if you have a one-phase microinverter or two-phase microinverter or three-phase, you can choose between our grid profiles to connect your devices to the network you are going to use. Also, you can see as well as as in the web page, you can see the information of production. You can order it by a week, or you can see it by month or by year. So it's very easy to use the application and get information of the production. This is the part of another part of the EMA manager on the website, where we can see the monthly energy of our systems, and also we can export that information to our computer if you want to make any analysis of the production. Maybe you want to see how the production varies through the year. Maybe you have some different months where in which you have more irradiation from the sun, and you can basically analyze the behavior of the system. You can do it here, and also you have some graphs that you can make a query to see it as well. Also, this is more for the technical part. For example, if you are a user, a final user, you can see the production. But if you are an installer, you want to see more than that, more than a basic information. You can see this information as an installer. For example, here we have some we have a little production here. For example, we have the DC voltage and also the currents. What does it mean? This means that we have we can identify, and also we can measure the input voltage that is going into our microinverter, and also we have the current that is flowing in the micro. So if we have the current and also if we have the voltage, of course we have as a result the output power. So if you are an installer and you want to see how much voltage you have in your system, you can see it through the EMA as well as all the information that I mentioned before. This is a special view. This view is for the ECUC. As I said before, we have the ECUC option if you want to measure the flow or energy from it comes from the grid, and also that the energy that flows from our system. So in this graph, we can see what is the energy we have. For example, in the night, of course, we don't have any generation. So in this case, we have just import power that we are using, and also consume power. when our system starts to generate, we have the production, and also if we want to export that energy to the grid, we can decide it through the ECUC and the CTs. And for example, here we have energy that is the production. We can see that the production is starting in the morning, and also that energy is exported to the grid. So in this case, we have the ECUC, but we don't have activated the zero export option, and we can export that energy. For example, we have here the consumption in this day. For example, we had 17.8 kilowatt hour consumed in the this is for the loads of the house or of the industry in which we measure. And also we have the export energy and import energy. This is the import energy that we import from the grid. And in total, we have this production in the day. So we have many information that we can use to measure our system. We have also our accessories. We can see here 3DS3D. This is obviously a chain of 3DS3D. We have the 3 devices, and for example here we have some Y3 cables, that is the trunk cable. Those are connected to each microinverter. So for example, if we want to unlock the trunk cable from the bus cable, we can unlock it with the unlock tool. This unlock tool is very helpful in order to unlock the microinverter from the bus cable. Also, we have the end cap. The end cap works its main function is to isolate the cables at the end of the chain, so we cannot. It avoids to use some tape or some another practice to isolate the cables. So the end cap, it covers all that. For the extensions, we have MC4 extensions. This is for the cable that comes from the solar modules. So you can see it here. For example, if we have some solar modules that are very away from the micro, we can use some extensions to reach the microinverter, the input of the microinverter. Also, we have the concap. This concap, we have two difference because for the bus cables, we have two types of bus cables. One is for the single phase and split phase microinverters, and one is for the 3-phase microinverter. So the bus cables are going to be different, but we have this concap for those devices. And this little device works to isolate the bus cable when we have a microinverter very away from another one. So it's like you are making like a bridge here, and you need to put a concap just to isolate this bus cable. And finally, we have the bus cable. The bus cable is this one that is here in the top. This bus cable function is to get the energy from the microinverters and also to connect it to the breaker. So for example, in a normal installation, you have the microinverters, you have the change of the micros. It could be 2 or 3 or 4, depending on the model of the microinverters. And then you connect it through the bus cable. And then you go to the breaker. We can use an auxiliary breaker just to control the microinverters. And then we need to go to the principal or the main box, electrical box in our installation. Okay, first we mentioned the microinverters, and also we mentioned the the communication units. So we need those parts to have an APsystems, an integrated APsystems in our houses. But what are we going to do to choose between microinverters or central inverters? Okay, if we choose to use the microinverters, we need to know which modules we are going to use. it's very important to, if you want some high power output models, you need to know the specific electrical specification, of the model. For example, you need to know the voltage of the model, and also you need to know the current, how many amps are flowing in that model. This is very important in order to choose the proper microinverter. Also, we have the option of the eDecider. This is a little app that we have on our website that it helps you to know which microinverter is compatible with your solar models. You can, we are going to see a link in the next slide to access to this little app. And then you have to identify the microinverter's serial number to synchronize to the ECU. And also you have to know how many current is going to flow in your bus cable to select the proper, to choose the proper breaker. Here, for example, we have a data sheet of a solar model. And this is basically the information that we are going to put in our eDecider, the APsystems eDecider, to know which microinverter is the correct to use in our installation. For example, here we have some the power output of the model, the temperature coefficient, and some information that we need to put in our eDecider. This is basically the face of the eDecider. It's very simple, and also we have here the QR code in which you can scan it, and it's going to take you to the web page, to this specifically this screen. In this screen, you need to put all the information here about voltages, about the short circuit currents. That is very important. Temperatures, and also some coefficients. And the final result is the recommendation of which microinverter is where you can use. For example, here we have 50 volts at open circuit, and we have 11.49 amps for the short circuit current. Then you can check compatibility, and the systems is going to give you some options of the microinverters you can use. This is very helpful because we cannot assume that all the people knows how the systems works, or maybe they don't have this full understanding of the solar module technology and how it works. So this information is very important, and you can go to the page and see which models you have, and see which microinverters you can use. For the warranties, as I mentioned before, we have 10 years warranties in the microinverters that use the ECU. So, for example, here since June 2021, all the devices, APsystem microinverters that are installed needs to have this ECU, because that is the way we can monitorize the system. If you don't have the ECU, you only have 2 years of warranty. So we can read it here. And also for the ECU, the little pieces of devices that I showed you for the monitoring systems, we have 3 years. That is the warranty, and that warranty applies from Mexico and all the LATAM. Finally, we have some examples of installations with microinverters APsystems. For example, it's very common that the people thinks that microinverters are just you can use it just for residential, or just to install 2 or 3 or 10 modules. But we have some very big installations. For example, in this case, we have 295 kilowatt This is the output power that we have. We have around 196 QS1 microinverters. So the installation is working perfectly. We can see here the layout of the installation. And also we have some graphs about the installation. Here we have the microinverters. This is just only view. Of course, we have many views from these systems, but this is an example of the view. For example, we have the first microinverter that is it ends with 6970. This microinverter has 4 MPPTs, so we have 4 lectures and one lecture from each module. So this is the view that we see when we have so many microinverters and so many modules. So it's very important to know that we can use the microinverter not only for residential, but as well as with commercial and with big output necessities. So for our side, this is everything. We have some QA site in our website that it's very helpful to go and see a question that some people had before. So we have some answer, we have some advices that you can see there. And also, it's very important to know that if you need some certification about our products, because some grid operators, some maybe they need some certifications in order to make an installation in your local area. So you can see all that information, certification, and the official documents from APsystems in our website. Also, we have this QR. This QR is for us. You can, if you can scan it, you can write some advices about our presentation, or you can give some opinions about what types of information you would like to have in the future. So this is the information, and thank you everyone for listening to this webinar.
Thank you so much, Alfredo, Soemi. Thank you for your presentation. Thank you everyone for joining us to this webinar. This presentation and this webinar we are going to send to you to your registered email. And I don't see any questions. So, I mean, if you have any questions about any project or anything, you have our contact. We are going to be we are going to be very attentive of you to help you in every requirement that you have. So commercial part or technical part, we are going to be for help you. So thank you, Soemi. Thank you, Alfredo, again for joining us for this webinar. I hope to see you very soon in another webinar, more technical, I think so. But yeah, thank you so much for joining us today.
Thank you, David. Thank you, Soemi, and thank you for all the people that watch us. I really hope you have a nice day.
Okay, bye-bye. Bye, everyone.
Bye.
Have a good day.